Hello everyone, this is Team 12 and my name is Akila Gorkala. So we have done a team project for SER502 Spring 2024. So our language name is Enigma Script. So coming to the next slide. So, about the Enigma script, we have created a language, Enigma script, that adheres to a specific constraint by ensuring support for basic data types, assignment operators, conditional and looping structures, and output capabilities. So, this Enigma script was created with an open source philosophy and utilizes the synergy of cutting edge tools such as Antler for parsing and Java for runtime. So we have used other tools that are IntelliJ and GitHub. So coming to the next slide. So the next slide is about the life cycle of Enigma script. So in the Enigma script pipeline, we start with the source code, which is meticulously broken down by Antler. So our chosen lexical analyzer into tokens. These token building blocks of language, capturing the essence of the code. Next, the parser takes these tokens to construct a parse tree, organizing them into a structure that represents our code logic. So from here, the code is translated into an intermediate form, an universal coding language ready for the interpreter. So then the interpreter executes this code, resulting in a final output. So this end-to-end process showcases us the efficiency and synergy of Enigma's design, transforming the written code into an actionable results. So now my friend Ujita will take over this presentation.
Yeah, Akila. So I'm going to continue about the life cycle of Enigma script. Next part comes the lexical analyzer because the life cycle consists of several stages: source code, lexical analysis, parsing, intermediate code, generation, and compilation. So basically, we use lexical analyzer, which plays a crucial role in process of compiling. It is also responsible for converting the raw code into sequence of tokens which represents the basic elements of language such as identifiers, operators, and symbols. Lexical Analyzer simplifies the parser's task by providing clean and organized token data, and it also organizes the code. The lexical analysis also converts the raw code into sequence of tokens, and then parser analyzes the tokens and builds a parse tree, ensuring the code confronts the language syntax rules. The compiler then transforms the high level language into an intermediate form understandable by the machines. So, parser analyzes each token and builds a parse tree that represents the grammatical structure of the program and is essential for understanding the programmer's logic. Next slide. As we have seen in our flowchart, compiler takes over our language and transforms high level into intermediate form, which converts into machine understandable language. During the compilation process, the compiler checks for multiple errors at multiple levels, such as lexical, semantic, and syntactic. Uh, Same as a compiler, interpreter allows the intermediate execution of Enigma script code, which is crucial for testing and debugging of our grammar. It also provides the runtime environment where the Enigma script code is executed. This includes handling inputs, output operator, code run, which the code runs correctly or not. Coming to the next slide. We have included many operations in our Enigma script, which includes data types, Boolean, integer, string. Next, basic arithmetic operations, addition, subtraction, multiplication, division, comparison operator, equality, greater than, less than or equal to, greater than or equal to, and logical operators, and or not. In the next slide, we also included few more operations: assignment operator, ternary operator, and unary operator, and intermediate blocks, while condition, for and for in the range, condition blocks if else, and else. So um, next slide. Uh, we have also included the symbols which we have discussed about the operators we have mentioned in this slide. And also for standard output, we have used print. For in the code, we have used comments, and you can see that. And we in identifiers, we have used caps and smalls and numbers 0 to 9. This ends the features of Enigma script. Next, my friend Saumit will continue.
Thank you, Ujita. So right now I will try to explain the grammar of our programming language. So as my friend Ujita has just explained about the addition operators, the data types, the comparison operators, etc. So the grammar defines the usage of all these operators. So according to our program, the code starts from the keyword Enigma start and ends at the keyword Enigma end. Then we can have various lists of commands embraced in a flavor bracket. So the plus symbol indicates that we can have one or more number of commands in a particular command list. And for a particular individual command, we can have Enigma if conditions, Enigma while loop conditions, Enigma for in range commands, Enigma for loop commands, or Enigma print commands, and Enigma assignment commands. So these commands, what does all these functions define can be seen below. So as the Enigma assignment command is defined, like you can either assign an integer with a and you can equate it to a numerical expression, which is 0 or 1 case. So you can either equate it to an integer, or you can leave it just by initiating it. And then you can do an integer, then you can equate the integer to a tertiary equation as well, just like as in Java. In the same way, you can do it for data types, Boolean and string as well. Then you can, after initiating the any particular variable, you can change the values by again equating it to a different numerical expression or Boolean expression. Then comes the condition. So the numerical expression and the Boolean expression conditions comes under the condition block. So the Boolean expression has we use the operators here, the AND operator, OR operator, and NOT operator. So as you can see, as my friend Ujita has explained before, the same operators are used in this particular Boolean expression values. And then the comparison expression, we use all the comparison symbols that are equal to, inequality, greater than, less than or equal to, greater than or equal to. These are used for comparing two different expressions, and the output will be basically a Boolean value. Then the numerical expression, the numerical expression is where, as in the above block we have discussed, right? Numerical expression now is defined as here. A particular expression or a particular variable is equated to another expression or another variable. So the question mark again portrays 0 or 1 case, where you can either use it or do not use it. Whereas the plus symbol indicates one to many cases. Yeah. Can you scroll down? Okay. Okay. So can you go a bit up above? Yeah. So the numerical expression is embraced within the evaluation expression is embraced within the uh, brackets, the normal brackets. Then the Enigma if command starts with the keyword if. Then we use the evaluation expression command list. Then we give the if else command, if else block. Then we use the if else block. Then that can be there, or it can be there, or it cannot be there. It is 0 to 1. So the star indicates 0 to 1. It can either have that block, or it may not not have it at all. Then it has to end with the Enigma else command block. Then the keyword to end this particular Enigma if command is end underscore if. So then Enigma if else command starts with else if. Then the evaluation expression, or the and the commands list, the whichever commands has to be done inside the else if block. Then we end the else if. So Enigma else command is the same scenario for everything. We started with the keyword else, then we have the command list, then we have the end else. In the same way for the while loop, we started with while, then we have the evaluation expression, and then the command list, and then end while. So for the print statements, we use at the rates in front of the strings for it to properly for it to print. Then for the other expressions, whereas the integers or variables, if you want to print the value of the variables, we just put the direct values in the embraced in the parentheses. Then Enigma for in range, then we start with the keyword for, then we type in range, then we in the parentheses, we give it a variable and then the range of that variable. Then we give the command list for it to print, and it ends with end underscore for. So the range values can either be a variable or is integer. So then Enigma for loop command, the for loop is similar to the for in range, but we do not mention the range here. We mention the Boolean expression or the Enigma variable. Mm, yeah, so operator is just like descending an integer with one. You can, yeah, decrementation, and then the increment operation is just increments the variable. We're using it before a variable, just increments the value immediately. Using it after increments the value after the execution of that particular line. So then the string then the Enigma yeah, the terminatory assignment, same as in Java. The same logic works. Same logic is defined here. Then the string integer. So these are all the values that my friend Ujita has already explained. So those are all defined in this part. Now my friend Hemant will explain the execution of the codes, and he will take the meeting forward.
Yeah, hi everyone. This is Hemant. Wait. Yep. So yeah, these are so yes, this is the sample command like for ternary operator, and this is the pass-through generator for the ternary operator by the grammar, which was used in the Antler. So similarly, have done sample codes for the all the data types and the for loops and print statements and while loops and ternary operator also in these things in the sample codes. These are the few sample codes which I have done covering uh, d- all the operations which I have declared. So yeah, run the let me run the sample test cases right now. So wait a minute. So for running the sample test cases, we need to make sure that the test cases and the jar file are in the same folder. And we need to open the command line at that folder only. Now, see, let me open the codes. Yep. So these are the codes. Like in this sample run, I have declared some variables and done basic operations, and I have printed those values. And similarly, yeah, I have done basic if-else statement and a Boolean type, and also checking a logical or and operations whether they're working or not. Those are the things I have done it. Let me run the program. So for running, so this is the output which have this is the output for the code which I have shown. Uh, Let me keep it side by side so that you can view it better. So yeah, basically the print statements are shown are from this only, from here. Like we are showing addition, so 10 plus 20 is 30. So these are the things we have done in this sample. And let me go to the next one, which shows the print statement and the for loop, normal for loop and the while loop and for in range loop. So let me run that file. So yeah, so I have written a basic operation which prints the numbers which in the range, like see from 0 to 10, like 0 to 10, less than 10 means 0 to 9, and from 10 to greater than 5 means 6 up till 6. So and from 10 to 15 means it starts from 11 to 15. So similar as Python. And for in test sample 3. So yeah, here sample in it shows the if else statements. And so right now we can see that both statements are equal. So it's printing as an equal. It's going to the else condition. So if I change the value and compile it again, so it's gonna be different, like A is greater than B. Similarly, again, once again. So yes, A is less than B. These are the basic if else conditions. So let me go to the ternary operator. So yes. Yep. Let me. So here we can see that A is greater than B. So it's true. So the first A is getting assigned in the C. So so the C value, when I print the C value, it's showing 10,000. So if I change the value and compile it again, I will get 1,000. So it's the B value. So it's going to be, since this condition is false, so it's going to be, and that's value is going to print. So, and the last sample test case is like factorial, which we are used, which we wrote in many languages. So I wrote again in this language also. Okay. So yeah, similarly 10 factorial value is this one. So if I change it again, it's gonna be different. It should show as 150. So here it's also showing while statement. I did the factors by using the while statement. So that's it from my side. Yeah, thank you.